Hello, welcome to Chapter 3.1, Linear Equations. In this lesson, we're going to learn how to solve linear equations. The addition principle of equality states that if the same number is added or subtracted to both sides of an equation, the result on both sides of the equation are equal in value. Thus, if A is equal to B, then A plus C is equal to B plus C, or A minus C is equal to B minus C. The multiplication principle of equality states that if the same number is multiplied or divided to both sides of an equation, the result on both sides of the equation are equal in value. Thus, if A is equal to B, then AC is equal to BC, where C is not equal to 0. In example number 1, we're asked to solve for x. And the equation is 8x plus 2 is equal to 42. So we want to isolate the x using the opposite operation on both sides of the equation. So that means we put negative 2 underneath the positive 2, so that makes that equal to 0. And then on the other side of the equal sign, we subtract 2. That means we're left with 8x is equal to 40. But we want to get the x all by itself. So now we have to divide by 8. And whatever we do on one side, we must do on the other side. So when we cancel the two 8's out, we get 1, which means 1 times x, and then that's equal to 40 over 8. And 8 goes into 40 5 times, so x is equal to 5. In example number 2, we are asked to solve for x. For 3x plus 4 is equal to 25. First, we want to isolate the x using the opposite operation on both sides of the equation. And in this case, it's negative 4, because here we have positive 4, so we balance it out to get negative 4. But whatever we put on one side, we must do on the other side. And this gives us 3x is equal to 21. Now we're left with 3x on this side and 21 on this side, but the x still isn't isolated. So we have to divide by 3 on both sides, because whatever we do to one side, we must do to the other side. So we cancel out the 3's, and that'll give us 1x or x. And finally, we get 3 goes into 21 7 times, and that means x is equal to 7. In example number 3, we're asked to solve also for x, but in this case we have 5x minus 9 is equal to 7x plus 11. Well, we want to bring the x's on the same side of the equation first. So in this case, I'm going to take the 5x by subtracting a 5x on this side, and then subtracting a 5x on this side. And that means these cancel out. I'll get 9x here is equal to 2x plus 11. But now I want to take the 11 where the x is not and bring the 11 over to this side. So if I have a positive 11 here, I have to now have a negative 11 here, and whatever I do to one side, I must do to the other. So now we have on this side negative 20, and we have on this side 2x, because positive 11 and negative 11 is equal to 0. Now we have to divide both sides by 2 to get the x all alone. And when we divide both sides by 2 on this side, that means we have the x isolated because it's 1x. And then 2 goes into negative 20, negative 10. And that means x is equal to negative 10. In example number 4, we're asked to solve 3x minus 9 minus x is equal to minus 16 plus x plus 19. Now, the first thing we want to do in this is to combine the like terms on both sides. And in this case, the like terms are the 6x and the negative 8x. So that means the like terms on this side are the x's. And when we put them together, we get negative 2x. On this side, the like terms are negative 16 plus 19. And if we add negative 16 plus 19, we get positive 3. We then bring down, from this side, we bring down the negative 2x, because when we combined 6x minus 8x, we got negative 2x. We bring down the negative 9, and that will be equal to positive 3 from here, and then the x from here. Now we can solve the rest of it like we did in examples 2 and 3. So in this case, I'm going to bring the 9s. I'm going to put the x's on this side, and I'm going to put my constants on this side. I'm going to divide this side by negative 3. And this side by negative 3 in order to get the x all by itself. And that will be negative 3 goes into 12, negative 4. Remember, a positive over a negative will give us a negative. So x all by itself is equal to negative 4. In example number 5, we're asked to solve for y, and the equation is 5y minus 2 plus 4y is equal to 5 plus 2y plus 7. So again, here we want to combine the like terms on both sides of the equation. In this case, we have a 5y here and a 4y here, so we're going to combine those two to get 9y. On this side of the equation, we have a 5 here and a 7 here, and we're going to combine those two to give us positive 12. So we're going to bring down the 9y and bring down the negative 2 from here, and that will be equal to the 2y from here, and then the plus 12 that we combined. Now we're going to balance it. We have a negative 2 here. I'm going to put positive 2 here, but remember, whatever I do to one side, I must do to the other side. So, and similarly for the y, I'm going to put negative 2y here to cancel it, and then 2y here, and I end up with negative 2y, and 9y will give me 7y. These will cancel out, and this will give me, these two will cancel out, and then these two together, 12 plus 2, will give me 14. Now I still need to isolate the y all by itself, and that means dividing both sides by 7. So if I divide both sides by 7, and here it'll give me 1, which will give me the y all by itself. So there's 1y or y, and then 7 goes into 14 2 times, so that is my final answer. In example number 6, I'm asked to solve for x, but I have 5 bracket x minus 3 close bracket minus 4 bracket 2x plus 7 close bracket is equal to 9 minus x. In number 6, I need to use the distributive law to clear the parentheses because I have these parentheses here and I can't do anything until I multiply through using the distributive law. So I must multiply 5 times x to get 5x, 5 times negative 3 to get negative 15x, and here I multiply negative 4 times negative 2x to get negative 8x, negative 4 times positive 7 will give me negative 28, and then I keep this the same on this side, 9 minus x. Now I combine the like terms. So when I combine the 5x and the negative 8x, I get negative 3x. And when I combine the negative 15 and the negative 23, I get negative 43. And that's equal to 9 minus x. Now I want to get rid of the constant or the number on this side, so in order to do that, I have a negative 43 here. I have to put plus 43 to give me 0. But remember, whatever I do to this side, I must do to the other side. So that leaves me with negative 3x. This becomes 0, and that will be equal to 43 plus 9, which gives me 52, and then I bring down the negative x. Now I want to take the negative x, the variable, and I want to bring the variable over to the other side. In order to do that, I have to add positive x, negative x plus x. And whatever I do to one side, I must do to the other side. So in this case, negative 3x plus x will give me negative 2, and that will be equal to 52 since negative x and positive x is 0. In order to isolate the x, I have to divide both sides by negative 2 because there's a negative 2 in front of the x. And this will isolate the x. When we divide negative 2 by 52, we end up getting x is equal to negative 26. And that is our final answer. In example number 7, we're asked to solve for a. And the equation is 3 bracket a minus 3 close bracket plus 6 is equal to 7 bracket 3a plus 1 close bracket. So this one I'm going to work out in detail on the whiteboard. Question number 7, we have 3 times a minus 3 plus 6 is equal to 7 times 3a plus 1. So we're going to use our distributive law here and distribute here to get 3a minus 9 plus 6 is equal to 21a plus 7. And we will combine these two to simplify things a bit. So that's negative 3, 3a
minus 3 is equal to 21a plus 7. And again, I'm going to make this side the side of the variables so that I will have it positive, and I'll make this side the side for the constants. So I have 3a minus 3 is equal to 21a plus 7, and minus 3a minus 3a. So I get minus 3 is equal to 18a plus 7, and then minus 7 minus 7, and minus 7 minus 7. Since that gives me 0, I can cross that out, and this one will give me negative 10 is equal to 18a. And we divide by 18, divide by 18. And remember, when we divide this and this, that gives us 1, so it's like saying 1a. And we want to simplify this, so we'll divide the top by 2, so that'll give us negative 5, and the bottom by 2 will give us 9, so that's just simplifying the fraction, so we get a is equal to negative 5 over 9. So don't be afraid that you have a fraction as an answer, because fractions happen. A lot of people will see a fraction and they'll do anything to get rid of it because they can't stand to see something that's a fraction. But when you eat pizza and you have only an eighth of a pizza pie, believe it or not, you usually only eat a fraction of a pizza. Most of us do not eat a whole pizza pie.
In reviewing what we just did on the whiteboard, we use the distributive property to clear the parentheses or brackets to get 3a minus 3 is equal to 21a plus 7. And then we added 3 on both sides to get rid of the negative 3 here, but whatever we do to one side, we must do to the other. And similarly, we did that to 21a by taking negative 21a and did it to the other side. So we ended up finally with negative 18a is equal to 10. And then we divided both sides by negative 18 and simplified it in order to get x is equal to negative 5 over 9. Yes, fractions do happen. In example number 8, we're asked to solve for x, where we have 9 minus bracket 4 minus 3, bracket x minus 7, close bracket, and close with the square bracket is equal to 11. So let us go to the whiteboard and work this one out in detail.
In question number 8, we are asked to solve 9 minus square bracket 4 minus 3 round bracket x minus 7 square bracket is equal to 11. Now notice that we have two sets of brackets. Well, whenever we see more than one set of brackets embedded in another set, what we want to do is we want to start with the innermost bracket and then go outward. So here we will start with the innermost bracket of negative, and we'll 3 times x and negative 3 times negative 7, where we use the distributive law. So we get 9 minus square bracket 4 minus 3x plus 21. Now remember, be very, very careful of your signing, because a negative times a positive is a negative, and a negative times a negative is a positive, is equal to 11. Then what we want to do is we want to gather the like terms. So that means here we have 9 minus square bracket minus 3x plus 25. And we close that bracket. And that's equal to 11. Now, when we multiply in that negative, it's like doing the distributive property and with -1. So we can do this. Again, be very, very careful of your signing. So we have to go 9 plus 3x minus 25 is equal to 11. Now what we want to do is gather these two terms. Now notice that we have a plus 9 and a minus 25, so that will give us a minus 16. So then we can rewrite this as 3x minus 16 is equal to 11. And then, of course, we put the 16 here. Remember, opposites, 16. And we end up with 3x is equal to 27. And then we divide by 3 on this side, divide by 3 on this side. And remember, when we have two things, one over the other, that are exactly the same, it's the same thing as saying 1 times x. And that means x will be equal to 3 goes into 27, 9 times, and that is our final answer. Again, you can just check by plugging the x in the original problem and making sure you get the right answer.
In reviewing what we just did on the whiteboard, we cleared the inner parentheses first. So then we got in the square parentheses 4 minus 3x plus 21. And then we combined to get 9 minus bracket 25 minus 3x close bracket is equal to 11. We dropped the bracket, combined like terms, and then solved for x to find that x is equal to 9. Now we're going to look to see what happens in example number 9. So we're going to go to the whiteboard and work this out in detail.
In example number 9, we have y minus 9y minus 8 is equal to square bracket 5 minus 2y minus 3 times 2y minus 3, close the square bracket, plus 29. Now, of course, we'll do like we did in 8 over here. Remember that negative outside the bracket is like using a -1 and distributing it through the whole thing inside the bracket. So we have y minus 9y plus 8, and we'll do similarly here, that innermost bracket like we did in an earlier problem. So that would be 5 minus 2y minus 6y plus 9 plus 29. Now what we want to do is we want to gather up like terms. So in the first one here, we see we have y minus 9y, and that's equal to 8y, and then plus 8. And then on this side, we'll just drop the brackets and carry over. So we have 5 minus 2y minus 6y plus 9 plus 29. Now we have our y's, and we get minus 8y. And then we add up all our other terms too. So we end up with negative 8y plus 8 is equal to negative 8y plus 43. And now we want to get, again, our variables on one side and our constants on the other. Now, in this case, it doesn't really matter. No matter what we do, what's going to happen, 8y, our variable will cancel out, and we'll end up with 8 is equal to 43. But that's not true. 8 cannot be equal to 43. So 8 is not equal to 43. So that means in this particular situation, there is no solution.
In reviewing what we just did on the whiteboard, we cleared the inner parentheses first, or the inner brackets first. We combined like terms. And we found that we got 0, which is not equal to 35. And we decided that what this means is that there is no solution to this particular equation, because it is not true that 0 is 35. So we know 0 is not equal to 35, and that means there is no solution. Thank you very much. I hope that you enjoyed this video. Take care, be well, and goodbye for now.